Today, on how it's made. Speed skates. Synthetic rubber. Cocoa beans. And bulk chocolate. The first ice skates were invented in Northern Europe about 1,000 years ago, when people began lacing animal bones to the soles of their boots to cross frozen water. In 1592, a Scotsman invented an iron skate blade, and before long, the sport of speed skating took off. These elite-level racing skates are produced by a small company co-founded by a Canadian speed skater, a 3-time Olympic medalist in short track. Every single pair is custom-made. After measuring a skater's feet, a technician applies layers of wet plaster bandages, the same way one makes a cast for a broken limb. Only here, each foot cast is comprised of 2 parts. Each cast serves as the first stage mold for a skate boot. The plaster bandages take 5 to 10 minutes to harden and dry, at which point the technician carefully removes the mold, 1 part at a time, then reassembles it with elastic bands. He surrounds the mold, called a negative, with sand. He then pours liquid plaster into the negative to produce a positive mold. The sand provides counterpressure so that the plaster can push the walls outward and distort their shape. The plaster fully cures in an hour or 2, at which point the negative mold can come off. The technician mixes up some thicker plaster, pigmented to make it easily visible against the dried white plaster. He applies it in select areas, touching up imperfections and tweaking the shape of the mold. He files the toes and the rest of the contour smooth, producing the final shape of the boot. He labels the finished mold with the skater's name and puts it in the storeroom until it's time to begin constructing the skate boots. Construction begins with boot lining. They staple a piece of genuine leather to the mold, pulling taut, because any wrinkles in the lining would irritate the skater's foot. They glue on the various structural pieces, such as this ankle padding. It's made of memory foam, so it gradually forms to the skater's ankle and holds the shape. The next step is the most technically critical because it determines the angle of the skate blade. They apply epoxy resin putty to the front and back of the sole, adhere 2 aluminum blade holders, then prop up the boot as the putty dries over the next 4 hours or so. Once the putty's hard, they sand off the excess to lighten the skate and round out the remainder. Then they begin constructing the outside of the boot. First, they layer pieces of carbon fiber, a strong fabric commonly used in high-performance sports products. They tie the bottom piece around the blade holders with strong thread and bond the layers with spray adhesive. Next, they slip a plastic bag over the boot, tie off the ends, and vacuum out the air. This tightly compresses the layers of carbon fiber. They inject resin, a type of liquid plastic, and distribute it evenly throughout the bag. The resin impregnates the carbon fiber. After a couple of hours, the resin dries and hardens, leaving the carbon fiber boot stiff and durable. Next, they glue on the outside of the boot, made of vinyl. Once the glue dries, they remove the plaster mold and stitch the vinyl in place. They also take a vinyl lace cover, sew one side of it to the boot, and attach the other side with a hook and loop fastener. That way, it hinges open and closed for lacing and unlacing the skate. The final step is to attach the inline wheels or steel blades to the blade holders. Synthetic rubber was invented in 1909, but the technology languished for a couple of decades. A shortage of natural rubber during World War II spurred its development. A kind of elastic plastic, it was actually more resistant to temperature extremes than natural rubber. Synthetic rubber reinvented the wheel. We're talking about the rubber tire. Tires for all kinds of vehicles are now made from it. This man-made material is also used to make everything from garden hoses to golf balls. Manufacturing synthetic rubber is now a computerized process, one that takes place under the watchful eye of a control room operator. He monitors numerous computer screens and live camera images. The plant itself is 400 meters long. There are a dozen or more enormous storage tanks for the raw materials, as well as several reactor units. The raw materials include a petroleum-based liquid called butadiene and solvent called hexane. They pipe these ingredients through columns to boil off any residual water, essentially purifying them. This is a laboratory demonstration of what happens next. They combine the purified butadiene and hexane and add a catalyst. The catalyst triggers a reaction that changes the chemistry. The mix becomes polybutadiene, a kind of synthetic rubber used to make tires. Adding another catalyst stops the reaction at just the right moment. The white milky liquid that exits the tank is synthetic rubber. They now pump in chemicals to tailor the rubber for a specific use, in this case, tires. The additives will increase traction and improve wear. A mechanized whisk stirs the additives into the liquid rubber. They pipe the synthetic concoction into insulated storage tanks. Inside, pumps mix it constantly so the additives don't settle on the bottom. Here's a close-up look at the liquid synthetic rubber in a laboratory beaker. It looks like a big vanilla milkshake, and it's about to be coagulated into crumbs. Here's where it all happens. This coagulation unit is like a big kettle. They pipe in the liquid rubber, a solvent mixture, and water. As they boil off the solvent, the rubber coagulates into crumbs the size of beans. The water remains because it has a higher boiling point. The mix of water and rubber crumbs bounces about in what's known as the crumb tank until it's time for more processing. Then they pump the mix into a rotary sieve. As it spins, it drains off the water. They add more water to cool the rubber crumbs. The rubber and water mix gushes onto a conveyor, which is a vibrating sieve. As the crumbs bounce along, the water drains off through the perforations in the conveyor. The synthetic rubber is now a lot like wet snow. Next, it's into the lab, where they aim a beam of infrared light through a sample to analyze the microstructure. If it's acceptable, production continues. A screw-like mechanism presses the wet rubber crumbs against a metal plate to squeeze out more moisture. Another trip on the next vibrating conveyor drains off droplets. Then, it's into a spiral conveyor. As the synthetic rubber travels upwards on the spiral, hot air is piped in from the side to dry it. Now mostly devoid of moisture but still sticky, the synthetic rubber crumbs head down a chute and into a baler machine. This machine uses pressure to compress the crumbs into big bales. The bales of synthetic rubber head down a conveyor towards a quality control inspector. This inspector examines them for imperfections. Once he gives them the okay, they head to the packaging station. As they travel through a curtain of plastic film, machinery heat seals it around them. These bales of synthetic rubber have taken about 6 hours to manufacture. And this purely chemical creation isn't much different than the real thing. Like natural rubber, it can be melted and shaped into many different things. Soon this batch will be turned into tires. And that's when the synthetic rubber will really hit the road. Cocoa beans are the primary raw material for making chocolate. They come from the fruit of the cocoa tree, native to Central and South America. The ancient Mayans would grind them up to make a special beverage for marriage ceremonies and other rituals. Today, cocoa is cultivated in the rainforest areas of many countries in the tropics. These cocoa beans from Costa Rica were cultivated without the use of chemical fertilizers, pesticides, or fungicides. Farming cocoa organically requires meticulous care and maintenance of the crop, along with grafting techniques to help establish disease-tolerant tree varieties. The farmer cuts a budwood, a young branch about to bud, from a healthy, productive tree and grafts it onto a sucker growing from the base of a tree which is either diseased or old and unproductive. She cuts a slot at the top of the sucker, then wraps a plastic strip around the budwood to hold in moisture until the graft takes. Next, she cuts a pointed end on the budwood and inserts it into the slot she made in the sucker. Then she binds the union and covers it with a plastic bag. Bagging protects the graft against two potential extremes, dehydration and excessive rain, which causes rot or fungus. If the graft takes, the union seals itself in a month or even sooner. Strategic pruning strengthens the tree and keeps it growing low and in a shape that's easy to maintain and harvest. Before long, flowers begin to bud and bloom. Tiny beetles pollinate the flowers, after which tiny pods, the tree's fruit, begin to emerge. The pods grow and gradually change color. When the color transformation is complete, they're ripe for harvest. There are many varieties of cocoa trees with pods of different colors. It generally takes about 5 months from first blooms to pod maturity. Come harvest time, they collect only the pods which are undoubtedly ready. If a pod isn't fully ripened, the cocoa beans inside will be acidic and bitter. They carefully cut the pod stem off the branch without damaging the tree in the process. The pod's rind is about 3 centimeters thick. It's rough and bumpy. They hack it open with a machete to remove the fruit inside. The fruit is made up of a sweet edible pulp encasing 30 to 50 large white seeds. These are the cocoa beans. The beans and pulp go to the fermentation area, where workers lay them in boxes or heaps and cover them for 4 to 6 days. As heat under the cover builds up, fermentation kicks in. The natural sugars interact with oxygen, the pulp slowly breaks down, liquefies, and drains away. The color and chemical composition of the beans change, and they become less acidic and develop a chocolatey taste. The next step is to dry the beans. Workers spread them out on big trays and lay them out in the sun for about a week. Here's what a cocoa bean is like wet versus dried. The dried beans now go through a selection process. Workers examine them, removing pod remnants and any beans with mold or other imperfections. Beans which fail inspection are sold locally at a lower price or go to the compost heap. Beans which pass are weighed, bagged for export, and sold to chocolate makers. Depending on the size of the beans, which varies according to the cocoa tree variety, it takes about 300 to 600 cocoa beans to produce 1 kilogram of chocolate. Chocolate owes its existence to the cocoa bean. The ancient civilizations of Mexico and Central and South America cultivated this seed to make a drink. The Spanish conquest brought this chocolate drink to Europe, but it wasn't until 1847 that a British company invented solid chocolate. This factory makes chocolate in various forms and sells it to companies which manufacture chocolate products for retail sale. It also supplies chocolate components such as cocoa powder and cocoa butter. Most of the cocoa beans arriving here come from West Africa, which grows 70% of the world's crop. A conveyor belt moves them through a cleaning system, a series of sieves which screen out twigs, stones, and other debris. Next stop is a micronizer, a revolving drum which heats the cocoa beans to loosen their shells. Then they enter a shell-removing machine called a winnower. Inside, successive rakes drag the beans across screens, pulling off large pieces of shell. Then a vacuum sucks away the remaining smaller pieces. Removing the shell exposes the inside of the cocoa bean, which is called the nib. The factory will roast the nibs to develop their flavor. More than 50% of the nib is fat, which is cocoa butter. To make chocolate, they'll combine processed nibs, cocoa butter, and sugar, along with milk powder if they're making milk chocolate. First, the factory processes the nibs by grinding them. The heat and friction activate the cocoa butter, producing pure liquid chocolate, called chocolate liquor. The factory extracts some of the cocoa butter to sell it separately as a chocolate-making ingredient and to use for in-house chocolate production, along with other ingredients in various proportions. The dark chocolate recipe, for example, calls for more chocolate liquor, sugar, and cocoa butter, but no milk powder. The recipe for unsweetened chocolate contains no sugar. The mixer blends the ingredients to the consistency of a very thick cake batter. The flavor is fine by this point, but the coarse texture needs to be smoothed out, so the chocolate moves to a refining machine, passing between a set of 5 rollers, which reduce the particle size. So much so that within just minutes, the chocolate leaves the refiner as a fine, dry powder. But now it needs to be reliquefied, so the next stop is a machine called a conch. The friction and heat once again activate the cocoa butter, returning the powder to a liquid state. At this point, they add more cocoa butter, enough to reduce the viscosity to the exact thickness they need. Just a bit, for example, if they're making chocolate chips, or much more if they're making a thin chocolate coating. For chocolate chips, the conch feeds a machine called a drop depositor. As the name implies, it deposits drops of chocolate onto a conveyor belt. The nozzle trays are interchangeable, so the machine can be set up to produce various sizes of chips, discs, or other shapes. The chocolate chips, still warm and soft, enter a cooling tunnel, traveling for about 5 minutes through several temperature zones, which vary between 10 and 15 degrees Celsius. By the time the chips exit the tunnel, they're hard. A conveyor belt then takes them through a metal detector, a standard food safety precaution. The factory also produces 4.5 kilogram bulk format chocolate bars. A depositor fills bar-shaped plastic molds. The conveyor transfers them to an elevator system, which moves through a cold room for about 2 hours. This constant motion ensures optimal air circulation, helping the cooling process. Chocolate shrinks slightly as it cools, so the bars pop out of the molds easily. To make the chocolate look as good as it tastes, the factory cools, then reheats the liquid chocolate before depositing it. This process, called tempering, promotes the growth of the most stable cocoa butter crystals, making the surface of the chocolate smooth and shiny.